Well, glad you could join me today. We are in week 2. It just seems like time has flown by. We had a great week 1, and I'll just tell you, I'm kind of in the thick of grading, making sure we get everything updated, and all of those good things. So here in the next day or so, be looking for feedback from the week 1 discussions, the week 1 assignments, so that you can make those corrections we talked about in during one of our live sessions last week. But this week we turn our attention to formulas, and this is going to be a good week for us to look at some formulas, some inequalities. We'll look at all of those today, get you some good examples. You will have everything you need for the live lecture quiz as well for this week, but let's take a look at what we have in week 2. So just like week 1, I have a to-do list, right? Because I shared with you my to-do list last week. I'm a huge planner and goal setter, to-do list, checklist. You've done your Enneagram. I'm an Enneagram 3, so it kind of goes right with that whole personality type. But I hope that this week we can see all of the things that we need to do, and then kind of check them off as we go. That's really the whole purpose of that. So I hope that helps with it. For now, I'm going to mute my video just so that we don't get any lag there. And let's take a look at the to-do list for this week. So for this week, we have 2 discussions as well. Don't forget that you want to jump into the discussions as early as you can, right? It's a great opportunity to work out your learning so that you kind of get a feel for this is what, this means, and this is what this doesn't mean, and all of that good stuff. So jump on those discussions quickly. As I said, I am still checking out the grading for week 1. So just a little bit of time, and I will take care of that. And get you some feedback, as I said, because I definitely want you to be able to correct those. Then you have the week 2 assignment. Now, I'm hoping you got my Canvas message already. And that message I sent earlier because I wanted you to have the playlist. So I created a YouTube playlist on my YouTube channel because I wanted you to see the examples that I created, and hopefully those will help you with the problems. Now, just a side note, if you play the playlist, be sure and don't shuffle it. If you leave them in the order that I have them in the playlist, then you'll get them in the order of the questions. So you literally play the playlist, and video 1 is for problem 1, video 2 is for problem 2, and so forth. I want you to have those to work with, and that way you have an example for every type of problem. Then the assessment, there is an issue with 1 question, and we're hoping to have that taken care of this week. Don't forget, you have more than 1 attempt at the assessment to earn the highest grade possible, so please use both attempts to be able to take care of that, get that highest grade you want. And then live lecture quiz. I will give you all the information you need in this session in order to be able to answer those 4 questions and do so very well. And then, of course, your daily checkpoints. Don't forget, there are 4 that you need to do that are required, and there are 3 that are available for extra credit. So take advantage of those. And I gave this reminder last week, but it really is true. I set a timer on my phone so that I can be reminded to do that. Usually the daily checkpoints take no more than 15 minutes. So I set a reminder on my phone each day at the same time to take care of those. So maybe that strategy will work for you as well. All right, so like I said, here's your to-do list for week 2. Now, in week 2, we have 6 learning objectives. Now, just like I did last week in session 1, I'm going to go through each learning objective. I'm going to explain the concept, and then I'm going to give you 2 to 3 ways to be able, that you are probably going to see that being asked. And that way you're ready and prepared for the way that these are going to be asked. Okay, so let's take a look at learning objective 1. This actually is a repeat of learning objective from last week. So let's just do a little bit of review because there is a problem this week on your assessment that has to do with a negative exponent. So I want to make sure that we understand and have a good review. So just a reminder that when we see a problem like number 1, 3 to the second, that means to write the 3 2 times and multiply. The 2, the exponent, tells us how many times to write that. So 3 times 3 is 9. Now, when we see a negative exponent, the first thing we want to do is come over to the side and deal with what would 15 to the positive third be? Well, that would mean to write the 15 3 times and multiply. So if we write that 3 times and multiply, getting my calculator here, I get 3,375. Now, how do I deal with that being a negative exponent? Well, I'm going to put that under 1. So I've got 1 over 3,375. The 1 goes on the top because of the negative exponent. And then whatever value we got for 15 to the third, that's the value that goes on the bottom. Okay, let's take a look at 7 to the 4th. 7 to the 4th means to write the 7 4 times. And we multiply. So again, going to my calculator to do that, I get 2,401. All right, let's do 10 to the negative 1. Now we'll come over to the side and figure out what 10 to the 1 is. That means to write 10 1 time. Okay, that's good. That's pretty easy. But now let's deal with the negative exponent. So now we put 1 on the top and that 10 on the bottom. Now the last one here is 5 caret 5. I wrote it this way because you actually can write it this way in your assignment if you need to. So 5 to the 5th power means the same thing. Write the 5 5 times and multiply. So we'll multiply all of those together and we get 3,125. So I hope that's a good review. Like I said, this learning objective was a learning objective from last week. But there is a question on your assessment for week 2 that I want you to be ready for with a negative exponent. So I think it's always good just to have some good practice with these concepts. All right, let's deal with a new learning objective for this week, and that is the radical. So what is a radical? So it's got some parts here and some terminology you may not have known what to call. So you have the radical symbol, we've got that here, okay? Then the index, The index tells us, we call this sometimes called the root, okay? Then you've got the radicand, that's the number underneath the radical symbol. And the whole thing can be called the radical. Now it's important to note that the index has to be positive. So this kind of is a lot of new vocabulary with what do we call this? And using the proper terminology sometimes helps us know where to put things. Okay, so if we have a radical that doesn't have an index written, see, like this is blank, we call that a square root. A square root. So for instance, if we don't have an index, see, there's no number here, we have the square root of 25, and that would mean, okay, what number times itself gives us 25? That, of course, would be 5. Now, another way we could write that is to write 25 to the 1/2 power. That 1/2 power actually means square root. So again, lots of different terminologies, lots of different notations that are meaning the same thing for us. So just a side note, again, if you have a radical where there's no index, that is called a square root. Okay, so what if there is an index? Okay, let's take a look at this example here. We have a 3 as our index. So what this means is, okay, what number multiplied by itself 3 times would give us 8? So look, if I do it with some blanks, I would have a blank times blank times blank, and that's got to equal 8. And these 3 blanks have to be filled with the same number. These 3 blanks have to be filled with the same number. That would have to be 2. Because 2 times 2 is 4. 4 times 2 gives us 8. So we say that that's the third root of 8, and that would have to be 2. So again, we could rewrite this as 8 to the 1/3. So whatever that index is, that index tells us how many times the number has to multiply by itself to get the radicand. Remember, that's the number underneath the radical symbol. Okay, so let's take a look. Which of this sample question, remember, after we talk about a concept, then I'll give you 2 to 3 different questions, the types that you might see with this concept. So, which of the radical expressions below would equal 4? Is it the square root? No index here. Okay, that would mean something times itself would have to give us 64. Or is it the third root? That would mean something times itself would have to give us 64. Is it the fourth root? And again, this is multiplying a number by itself 4 times to give us 64. Or finally, is it the fifth root? And see, my friends, all we have to do is decide which one of these, when we put the 4 in there, in the blanks, do we get 64? Well, 4 times 4, that's not 64. That doesn't work. 4 times 4 times 4. Ah, that does give me 64. So I know my answer has to be B here. So really hone in on that index, okay? That index tells us how many blanks we need to multiply together in order to get that radicand, which is the number underneath. Okay, so which of these would equal 3? And let's put our blanks out there because I love that visual. This means some square root, no index, right? That means something times itself would give you 24. Then with an index of 3, we get something times itself 3 times to give us 64. Okay, or something times itself 4 times would give us 64. Or finally, something times itself 5 times. That's what that root tells us. That's that index, I should say. I'm in an old habit of calling it a root. So here's the difference. We've got to figure out which one of these can we put 3 in. And why did I put 64? It's not 64. It's 81. Well, that's a quick fix. No worries on that. We just need to know which one do we put the 3's in. 3 times 3 is 9, not 81. 3 times 3 times 3, so that's 3 times 3 is 9, times 3 again, that's 27, that doesn't work. So 3 times 3 times 3 times 3, bingo, that's the one we wanted here. Okay, so again, I'm hoping you're seeing that index is telling you how many blanks do you need in order to be able to get the radicand, that's the number underneath the radical. All right, so let's try some of these, okay? Remember what we're trying to do. Notice on number 1, we've got an index of 4. So we're saying, okay, what number times itself 4 times gives me 625? Well, it ends in a 5. So I'm leaning to believe that this might have a 5 going on. Let's check and see if it has a 5. See, when numbers end in a 5, I know there's generally a 5 being multiplied as well. So let's check this here. 5 times 5 is 25. Times 5 again, 125. Times 5 again is 625. So this works. So this would equal 5. Okay, let's look at number 2. This time we're looking for the index. Okay, so how many blanks do I need to get 216? Okay, well, I know 6 goes in the blank. So 6 times 6 is 36. Times 6 again is 216. So that works. So I need that index to be 3. I need there to be 3 blanks. I need there to be 3 6s being multiplied together. All right, look at number 3. No index. That means 2 blanks, right? Understood to be 2 blanks. What number times itself would give me 121? I think that would be 11. 11 times 11 gives me 121. All right, look at number 4. We know 2 goes in the blank, and we know there are 5 blanks. So 1, 2, 3, 4, 5, and we know 2 goes in each blank. So we're trying to get the radicand, right? So we just need to multiply these together. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 should be our radicand here. All right, and then number 5. Oh, we switched up the notation here. Okay, so notice your index is on the bottom. This is really saying the 3rd root of 512. That means there are 3 blanks, and we need it to equal 512. Well, first of all, because 512 ends in a 2, I know it's got to be even. And I already did 6 back up here on number 2. So I'm going to jump into 8. Let's see, I've got 8. And 8 is 64. And 64 times 8. That is 512. So that works. So we get 8 here. Now, friends, you can also use the Desmos graphing calculator. If you haven't used it before, be sure to just Google Desmos graphing calculator. It's a great tool. If you want to check some of these, you can put in your square roots and your third roots and so forth, and it will help you check your arithmetic, but of course, check your multiplication as well. It's completely free and online graphing calculator. That's why I always recommend that as one of my tools. All right, let's take a look at our next learning objective, and that is to describe inequalities. Now, we have a ton of inequality symbols here. These are the symbols that we see used with inequalities. We have less than, greater than, less than or equal to, greater than or equal to, and I want to highlight the difference in the last two is simply that line underneath the less than or the greater than. So you've got a line under there that indicates the equal to. These are the only four symbols that can be used with the inequalities, so make sure any other symbol would not be used with an inequality. So let's take a look at two examples that are very similar. The first example, you see x plus 3 equals 12. Now, we know that x equals 9 because 9 would be the only number that you could add 3 to and get an answer of 12. However, when we look at an inequality, x plus 3 is greater than 12, we know that any number that's bigger than 9 could work, meaning 10 plus 3 is greater than 12. 11 plus 3 is greater than 12. So when we give our answers to an inequality, we have to say it in describing the numbers, and this would be any number that is bigger than 9 would work, because any number bigger than 9, you could add 3 to it, and you would get an answer that's bigger than 12. So when we do an equation, we get an exact one answer. When we do an inequality, we get a description of a whole bunch of answers that could work. So let's take a look at the way we could see this type of question. So for the inequality, 3y is greater than or equal to x, which would be a solution. Well, let's check this first one on A. I've got 3y is greater than or equal to x. So if y is 2, I'm going to put in 2 for y, and I'm going to put in 8 for x. So now 3 times 2 gives me 6 is greater than or equal to 8. That doesn't work. So I know A, it doesn't work. Can't be a solution. Let's try B. I've got 3y is greater than or equal to x. Okay, we're putting in 3 for y, and I'm putting in 2 for x. So 3 times 3 is 9, is greater than or equal to 2. 9 is greater than or equal to 2, so I know this is correct. Okay, let's do C. I've got 3y is greater than or equal to x. So I'm going to put in 3 for y. 3 times 3 is greater than or equal to 3. 3 times 3 is 9. 9 is greater than or equal to 3, so this is true as well. All right, let's do 4. Let's do D, where y is 4 and x is 1. So we'll do 3 times 4 is greater than or equal to 1. So 3 times 4 is 12. That's true as well, so it works. So I've actually got 3 here that works, because remember, when we have an inequality, we have a bunch of answers that could work. When we have an equation, many times we have 1, maybe 2 that could work, depending on the equation. Okay, let's do one more like that. So for this one, I've got two. So this one I want, which one is not a solution? Okay, so we start with 2x is less than 4y. And we put in 7 for x and 2 for y. So I got 2 times 7 is less than 4 times 2. So 2 times 7 is 14. Is less than 4 times 2 is 8. Okay, 14 is not less than 8, so this is not a solution. Remember, we're doing the reverse of this one. We're identifying the ones that are not solutions. Okay, let's do B. I've got 2x is less than 4y, and I've got that x is 5 and y is 2. So we'll put in 5 for x and 2 for y. Okay. So 2 times 5 is 10, and 4 times 2 is 8. 10 is less than 8. That is not true either. So I know B is not a solution either. Okay, let's do C. I've got 2x is less than 4y. And I'm going to put in 4 for x and 4 for y. So 2 times 4 is less than 4 times 4. 2 times 4 is 8. 4 times 4 is 16. This is true. So I know that 4 is a solution. So I'm not going to choose it to say it's not a solution. All right, and then let's do D, 6 and 3. So I've got 2x is less than 4y. So I'm going to put in 6 for x and 3 for y. So 2 times 6 is 12, and 4 times 3 is 12. Uh-oh. I've got 12 is less than 12. Now think that through. Is 12 less than 12? No, it's not. So this is not a solution, which means in our case that we select it as an answer because we were looking for those that are not solutions. That's tricky. Okay, be real careful with that. You don't want to get caught up on that. You've done all this beautiful math and then miss it at the end because we said that 12 is less than 12 is true. Okay, so practice with these, right? Make sure you substitute in for the right variable. You do your calculations and then look for, is it true or is it not true? So I want to finish up with this problem where we're going to solve this inequality because I've got two things here. We talked a little bit about solving inequalities in our we solved it in an equation. And I want to walk through how to solve an inequality like this. So the first thing is I want you to notice the variable is here. We ask ourselves what's happening to the variable. It's being added by 4,000. It's being multiplied by 0.25. So the first thing we're going to do is to get rid of this 4,000. It's being added. So we're going to do the opposite of adding 4,000, which is to subtract 4,000. So I'm going to subtract 4,000 on both sides of the equation. So when I do that, 4,000 minus 4,000, those go away. I'm left with 0.25x is less than, and then I've got 20 minus 4,000, which is 16,000. All right, then I've got to get rid of the multiplied by 0.25. So the opposite of multiplying by 0.25 is to divide by 0.25. So we'll divide both sides by 0.25. Now this is probably where you want to go to your calculator. And that's where I get that x is less than 64,000. So any value less than 64,000 would be a true statement here, would be a solution, another way to say that. So, all right, we call these two-step inequalities. Obviously, two things we had to do to get the variable by itself. The first thing was to subtract 4,000. The second thing was to divide by 0.25. All right. Let's switch our focus now to our next learning objective, which is about polynomials. We want to define polynomials and variables. In week 1, we talked about the terms coefficient, variable, and constant. Now, in this week, we're going to focus in on the polynomial part. Now, polynomials are simply an algebraic expression with many terms. These terms are often separated by a plus or a minus, okay? And each term can contain variables with or without coefficients or constants. But I think this 4th bullet point is key. Exponents in a polynomial can only be positive. And the last criteria, individual terms can contain division symbols, but polynomials cannot contain division by a variable. That's important. And I'm going to show you some examples here in just a moment. So here we have, at the example I have at the bottom, we have a polynomial. There are 1, 2, 3 terms. There are 2 variables, x and z, and 1 constant, 13. So let's take a look at this sample problem. Which of the following could be considered a polynomial? So look at A, that was the one we gave an example. So yes, this one can be. So B looks really good except for this second term here. I see it has division, but is it a division of variable? Are you dividing by the variable? The answer is no, you're dividing by 4. So this is a polynomial. So A is a polynomial. B is a polynomial. Oh, if I can spell today. Look at C. I see that variable has a negative exponent. So this is a no. This is not a polynomial. In D, we have a division and we are dividing by a variable. So again, that is a no. That is not a polynomial. All right. Let's see, our next learning objective is to define algebraic formulas and list 10 types of algebraic formulas. Okay, so an algebraic formula is a type of formula that's used to solve for an unknown number that can represent just about anything, from distance traveled to temperature conversions. So an algebraic formula is simply a formula where you're looking for an unknown value. These formulas can be used in any and all career types. So a lot of times I hear people say, well, I'm never going to use this type of math. And what they're referring to is they're not going to go through these steps to solve for it, right? They may use other processes, but they are using some type of formula. They may just not be writing it down. They may not be wanting to call it that, but we are using a ton of formulas. So our second bullet point here, lots of careers use specific formulas to help with calculations. In fact, we looked at 3 of them last week during our live session. So we're going to look at some more today. So the formula assets minus liability equals equity. We dealt with this one last week, can be used in accounting, where A represents total assets. Now, total assets, for those of you who are not accounting, that refers to cash and inventory. L represents the liabilities. That's accounts payable and lease payments. And E represents equity. So the question is, if the client has $4,000 in liabilities, now, friends, I'm one of those people, I just put the letter right there. That's L. And it has $25,000 in assets. That's A. How much equity would it have? So I'm going to take our formula, assets minus liability equals equity. I'm going to take these values. I'm going to take that $25,000. I'm putting it in place of A. So I've got $25,000 minus, I'm taking my liabilities, I'm going to put that in for L, that's 4,000, and I'm going to look for the equity. So 25,000 minus 4,000, that's 21,000. And see, friends, how we found our equity. Now, again, our accounting people say, well, I don't use those formulas. We do. You may just have subtracted in your head. For this one, it actually can be quite simple. All right, look, another formula here. Love this one. And by the way, you do have one like this on your assignment. Check out my playlist from YouTube. My YouTube playlist I created because I have an example of every single one type of these. Okay, so this is the formula we use to convert Celsius to Fahrenheit, where F stands for Fahrenheit temperature and C stands for Celsius temperature. Use the formula to find the equivalent for 32 degrees Celsius. So that's our C. And I'm just going to flip over to the next slide here for us to be able to run some or do some equation work. So we have F equals 5/9 C plus 32. And we were being asked to find out, okay, what is the Fahrenheit equivalent of 32 degrees Celsius? So we're going to put in 32 for C. I've got 5/9 times 32, and then I'm going to add 32. That's we're going to have 5/9. If you're dealing with a scientific calculator, let me tell you how I do this. I do 5 divided by 9 and times 32 plus 32. So do 5 divided by 9, then times 32 plus 32, and I get a decimal, which I'm going to round. I get 49.8 degrees Fahrenheit. So really what we're doing, we're taking that formula, we're substituting in a value, and we're finding the other unknown. Finding the other unknown. Okay, let's take a look at another one. So here is a formula that is often used to find distance. So D equals RT, where D is the distance, R is the rate, T is the time. So let's look at our problem, okay? Keith drove his truck an average rate of 45 miles per hour. I'm going to put an R there because that's what that means. And arrived at his destination in 4 hours. Okay, so that's time. How many miles did he travel? So again, we're making these substitutions. We're going to put in 45 for R. Oh, did I have the wrong one, Felicia? Did I have the wrong fraction? Ah, okay. Let me finish this one. I'll go back and fix it. All right, so I've got distance equals R times time. So again, we're putting in 45 for my rate, and I'm putting in 4 for my time. So 45 times 4 gives me 180. And that would be miles here. Okay, so thank you, Felicia, catching my mistake. Let's go back here. Ah, check out that fraction right there. Okay, so let's fix it. I gotta love good eraser. It's gonna make it a little bit nicer answer, truthfully. Okay, so now it's 9/5 C, 9/5 C, 9 divided by 5. So 9 divided by 5 times 32 plus 32 gives me 89.6. Much nicer answer. Thank you for catching that. I definitely want it to be right here. Okay. Let's look at our next formula. This one is can be used to find the area of a circle. Area equals pi r to the second, where area, A is area and r stands for the radius of the circle. So just remember some terminology. Radius is from the center to the edge. This is the radius. So let's look at our problem. A landscaper needs to know the area of a circular plot of land for a garden. If the radius is 12, you know I'm going to put an R there, what would the area be? Okay, let's create some more space here. I've got area equals pi times radius to the second power. And we know that the radius is 12, so I'm going to put in 12 for my radius. Remember what second power means. That actually means to write the 12 twice and multiply. So 12 times 12 gives me 144. At 144 pi. Now, a lot of people like to use 3.14 as their approximation for pi. Even though there are more decimals after it, we'll just use 3.14, make it nice and easy for us. And so my area is, oops, not 300, but 452.16, and this is square feet for the area of that circle. And again, there are some good problems like this on your week 2 assignment. I did 2 problems like this for examples. I believe there are 2 examples because there's 2 problems on the assignment like this. So check those out as you're working through them. Okay, let's look at this problem then. The formula below can be used to calculate the circumference of a circle. C equals 2 pi r, where C stands for the circumference. By the way, the circumference of a circle would be a bug traveling all the way around this circle. That would be the circumference. And the R stands for the radius. So let's take a look at our problem here. You can determine the distance a tire will travel in 1 revolution by calculating its circumference. Find the circumference. Excuse me, I tried to mute before I sneezed, but find the circumference of a tire that has a radius of 15 inches. There's my R there. And let's go and use our workspace here. So we've got circumference equals 2 pi times R. So we know the radius is 15. We'll put that in there. And we'll use 3.14 again for our pi. And let's multiply. 2 times 3.14 times 15. And that gives me 94.2. And I think it was inches for that one. So again, you're using your formulas, you're making a substitution for the variables, for the letters that you are given, and then we are finding the other unknown value. So just a quick recap. Remember that in order to be a polynomial, there can be no division of variables and no negative exponents. So check your denominators, those are just numbers, so we're okay. No division of variables, no negative exponents, that works in B. C, no division of variables, no negative exponents, we're good there. Uh-oh, division of variables, that's why D is not going to work here as a polynomial. In each polynomial, determine what the coefficients, variables, and constants are. So coefficients here, we've got 8, 2/9, and actually we've got 1/4 there. My variables are Z, and Y. Okay, let's look at B then. My coefficients are -3. My variables are X and Y. and my constant is 14. Now C, I don't have any coefficients because I don't have any variables. I have some constants, 5 and 18 to the 7th. Those would be constants. And then finally, coefficients would be -7. And my variables here would be Z. So I hope that helps with this week. We have a lot of extra problems here. I'm going to stop my share. I have a lot of extra problems. I will be sharing some of those and others in our in another session where I'm going to do an open Zoom room later this week. If you want some extra practice, you're welcome to come to that. But I hope this has helped. I hope it gave you enough tools. And like I said, I love this first session to be, here's the learning objective, here's what we do with it. Here's the learning objective, here's what we do with it. Here's the type of questions you're going to be seeing. But thanks so much for coming. Thanks for being attentive, and I hope this helps with week 2. Bye.